it goes like this. Okay. If you look at any picture of the moon taken by anyone anywhere on Earth, you'll notice that they're pretty much the same. It might be upside down or slightly rotated a little bit because of libration, but the moon, the face itself is exactly the same, or not exactly, but it's pretty much, there's a little bit of a rotation that you can notice on the extreme ends. But other than that, it's the same face. Well, look, if you map this out, if you draw this out on a piece of paper or model it in a modeling program or whatever you want to do, make the model, 25,000 miles across to, round it up. Put the moon 3,000 miles above it, and then put the moon over Kenya. Make that like the center part. Okay, not the center of the map, but you'll see what I mean in a minute. And then far to the west of that, mark Brazil, like the eastern edge of Brazil. And then on the other side of the map, mark Sumatra, Indonesia. That's going to be far east of the moon. Now, the people in Brazil are going to see the moon on their eastern horizon, and the people in Sumatra are going to see the moon on their western horizon. Well, right now you might be thinking, so what? Well, here's the thing. If you look at which angle each one of those people are looking at the moon or seeing the moon from, there's no way they could see the same face. I mean, those two positions in relation to the moon are more than 90 degrees apart. They would see completely different moons, but we don't see that. But they all look the same. And by the way, the person in Kenya looking not exactly straight up, but pretty high up in the sky, they're going to see yet another view of the moon. The only way to fix this is to move the moon hundreds of thousands of miles away, like 235,000 miles away would do it. But the problem is, if you do that with the moon at its flat Earth size, 32 miles across, it's too small to see. So now you have to make the moon bigger so that it matches the size that we actually see it in the sky. Okay, so you have a moon that, in order to fit what we actually see on the flat Earth model, you have a moon that's over 200,000 miles away and is about 2,000 miles across in diameter. So you might think, okay, well, that fixes the problem. Yes and no. Sure, now everybody on Earth would see the same face of the moon. But now you have another problem. The problem is that if you move it that high up, the horizon can no longer hide the moon like you do on the flat Earth model, because there is no horizon if it's way up there, So the moon, if it's that high up, is going to be visible to every person on Earth 24 hours a day, 7 days a week. I mean, and that completely screws the flat Earth model as far as the moon goes. And since during a solar eclipse we can watch the moon move across the sky and then obscure the sun, we know that the sun is farther away than the moon because the moon is in front of the sun, obviously. So now we know that the sun is also at least 235,000 miles away. So those two things right there, I don't see how you can recover from that. Some of you might be thinking, well, the moon could be flat too. So here's the problem. If you make the moon flat, yes, everyone would see the same face of the moon, but the problem is now it only will be circular if it's directly over you. If it's farther away, it's going to be like a squashed or stretched ellipse. And since that isn't what we see, that's not the answer. Of course, if you move it 235,000 miles away, it works. But then you have the other problem again. Everybody can see it 24 hours a day, 7 days a week. I will be very surprised if anybody can come up with an answer for this. I don't see how you can unless you make up something, which it wouldn't be unusual for the flat earthers. But try to make up something that makes sense and matches what we actually see. Good luck.